rest after a further 20 seconds. So we are told to draw a velocity time graph, draw a graph for the motion, use the graph to determine the maximum velocity reached, the retardation, and the distance covered. So we want to look at here. Now we say a train starts from rest. So if a train is starting from rest, so in our solution here, if a train is starting from rest, that means the initial velocity for the first stage, we refer to this as first stage. For the first stage, our initial velocity is 0 meter per second. Then our acceleration a1 is 2 meter per second square. 2 meter per second square. Meter per second square. So then, until it attain a maximum velocity in 20 seconds. So the change in time, which is our t0 minus t1, change in time, which is our t1 minus t0, will be 20 minus 0, which is 20.0 seconds, or 20.0 seconds. That's our change in time, 0.0 seconds. So that's the 20 seconds. So you maintain this velocity for 60 seconds. So since we talk about maintaining this need for 60 seconds, so we have our second stage. So we can say from here our second stage. Oh, before we get our second stage, we've not gotten our final velocity. So from here, our final velocity is not gotten. But how do we get final velocity? We have to start with the equation of motion for v is equal to u plus at. So this is be u1, v1, a1, and this will just be my change in t. So you know my v1 will now be my u1, which is 0 plus a, that's 2 times 20. So from here I now say my v1 is equal to 0 plus 40, which is 40 meter per seconds. That's 40 meter per seconds. So through that we know that my v1 is 40 meter per seconds. That's settled. So let's move to the second stage. For the second stage of our motion, if you note this, our v1 is also the initial velocity